So last time we met, we mentioned that projects are complex, especially when we're working together in multiple folks in large teams, and that projects were most vulnerable at the beginning when we were all agreeing on what is that we were building, right? When we were defining the requirements, and that there's a long list of failures that would give pause to investors, right? When they look at some of these statistics, that a third of the projects are going to fail, and when there's a lot of money involved, trillions of dollars, they're saying, if would I play this game knowing that I have so little chances of success? So that even though a lot of them are going to be complete failures, quite a few others are going to be going to need much more money, much more time, a lot of rework. So it gives investors pause looking at some of these numbers, some of these statistics, and some other newsworthy failures in history are listed here, up to 2006. Certainly many more. So one of the questions is, why does this happen? What is it about all these projects that causes them to fail? So certain aspects that have been common amongst all these failures is the lack of participation by the various constituents, stakeholders not giving feedback on some of the requirements that we're asking more specific questions about, that we lack some of the planning and management skills. We chose maybe the wrong technology, or we just don't have the skills for implementing a particular solution. So this course, is about trying to make sense out of all these challenges, and what are the techniques that we can do to minimize the likelihood of failing on a project. So first, it's useful to take a look at who's involved in a project. Obviously, the client with an idea, with a problem that they need solved is usually where it all starts. That there's some business need. That from that business need is where everything else flows, right? So anything that we're building, hopefully, is based on solving a particular problem. Unless you're working in research and development or some fundamental research, usually it's whatever you're working on is based on solving a particular real problem. So you have all sorts of folks that have input into the project. Finances, lawyers, marketeers, bosses, sponsors, clients. And also the team that is involved. So you have all these moving parts that are trying to agree on what is that is being built. So we have identified why projects might fail. We like to know why. What about the bulk of it? Most of them are successes. What is it that make them successes? And some of the aspects that we find is support from our superiors, from the management team. Some of the system engineers and the business analysts knowing how to say no, or making sure that they provide a not too much of a rosy picture of what the process is going to be, have a realistic schedules, to be able to negotiate what aspects of certain features are going to be able to negotiate the schedule. That you can't fix both the schedule and the scope, right? If you need more scope, you're going to need more time, right? You can either set a fixed schedule, but then allow us to negotiate what the scope of the project is, or fix what the scope is, but then allow us to negotiate on the time that's going to be delivered. So some of the aspects that we find in poor management is, especially in immature teams, is teams that feel that you can code your way out of anything, right? That your default is to be narrow and sit in front of your computer and actually code your way through it. In more mature projects, there's a lot of sitting around and thinking and architecting and planning on how is it that you're going to be building something to then go in and be as more effective as you can. Also, oftentimes in poor management, we don't have an objective way of measuring, how successful are we? How far along are we? We in immature teams, we tend to give a fuzzy feeling on how far we are along. And 1 week we say we're 50%, the next week we say we're 95%, and we're kind of stuck on that 95% for the next couple months. And so there's no objective way of measuring, of knowing how actually are you done, right? How long are you? Also, the fact that we don't realize that requirements are going to change, right? That we might be adverse from change, and we want to fix those requirements, and we don't have a process to manage those changes. Changes are going to be inevitable, so we need to have a process to allow those changes to occur in a formal setting. Also, we're not formal about our testing. The schedules are fairly arbitrary. It needs to be done by the third quarter or by the end of the year. There's a lot of these dates are fairly arbitrary. Also, we in poor management, we tend to sacrifice the quality because we have a demo that's coming up. We have to have something to present to our managers, and we start doing shortcuts just because we have to meet a particular schedule, right? And we incur in a lot of technical debt that at some point we're going to have to pay down. Good management. Some of the aspects of good management is that we look for formal methodologies, that we look for objective ways to measure our progress, that we negotiate the scope or we negotiate the schedule, and it's more realistic. A mature manager will ask their developers, how long do you think this is going to take? As opposed to imposing what the schedule should be. We kind of the manager tells the developer, don't be over optimistic. If you say a week, I'll give you 2 weeks. It is the manager's take on giving you more time than you actually need. Right? It's better to be early than to be late. Right? So solutions, how to tackle all these challenges. So many of the solutions over the history of solutions in software engineering have spanned across these two dimensions. One of them is dealing with whether the process of dealing with software engineering is a sequential process where you go through several phases once, right? But only through several defined phases. Design, implementation, testing, and whatnot. But it goes just once. As opposed to iterative, where you might apply the same 5 different phases, but multiple times with smaller chunks of the scope. So that's one dimension. The other dimension is whether your process is very structured, very fixed, very unchanging, where you don't allow requirements to change over time, as opposed to welcoming those changes, realizing that changes is inevitable, and feeling comfortable with a chaotic movement of lots of moving parts. So again, that's another dimension, and there's several methodologies that fall in different quadrants of how adaptive, how rigid, how sequential, how iterative over time. So the sequential approach is focused on saying, well, we're going to start at the beginning, and at the end, we're just going to deliver something, and hopefully it's what you asked for, and it's one shot, right? So that's at one extreme of being sequential, of being adaptive. On the other extreme is anything goes, right? We're gonna have an iterative, small chunks of work, and at each iteration, we're going to give you small increments of something that is going towards a solution. The most famous type of sequential approach is the waterfall, which most of you will be familiar. Very structured, very heavy on documentation. We don't proceed to the next stage until the previous stage is completed, right? Until we don't have a full plan of what we're going to do, we don't go on to design. And until we don't complete all the design, we don't go on to implementation. and it's very, very strict, right? Obviously, it's a continuum, not it's not only to the two polar opposites. There's any level of variability under that particular dimension. Usually it's different teams in different stages. There's a different team that plans, a different team that designs, a different team that implements, a different team that deploys and manages the application. Usually they prefer the specifications to be fixed. They don't encourage or welcome any changes over time. The problem is that usually it's way too early to plan anything if you don't really know what the design is or some of the knowledge of these requirements are going to change over time, and so the stakeholders are being asked to commit to something they don't fully understand, right? That even they're going to commit on something that they know it's going to change over time as new challenges to the businesses come in from competition. So it's very, very hard to predict the schedule. The farther out you're asked to plan, the less likelihood is that you're going to be right on that particular schedule. The iterative takes the opposite approach and says, well, no, instead of trying to plan out something that's 2 years out, right, that it's probably going to be wrong, let's try and plan this week, right, or maybe this month. But don't ask me what's going to happen 2 years from now. Whatever I tell you now is going to be irrelevant at the end of this year. Never mind 2 years out. So instead, let's try to bite off smaller chunks, right, and plan and design and implement that a week from now, or 2 weeks from now, or a month from now, right. So the iterative tells me, and then apply those same 4 or 5 phases this week, and then we'll apply it again next week, and then we'll apply it again next week. So there's smaller chunks of design, smaller chunks of planning, smaller chunks of implementation, smaller chunks of testing, where at each iteration we provide a small incremental value to the final product, and this is just a note on not to we've us developers feel most comfortable in our own IDEs, in our own code that we can control, and sometimes we are adverse at dealing with folks, and rightly so. Folks are messy, but coding is necessary. Good coding is necessary, but certainly not enough, right? Not enough.